Okay, I'm going to go through an example here of determining the rate law using data, just to be specific about this. I also recommend watching the Khan Academy video on this if you need to go a little bit more in depth. But if I give you something like this table, you've got multiple trials here, and I want you to tell me what is the rate law for this reaction. So what you're going to do, the rate law should be written as equals K times, and then you need to look at each reactant. It's A to the first zero power or first power, second power, B to the zero first or second power, figure out. So first I'm going to look at A. So what you need to do is choose two trials where A is changing, but B isn't. Okay, that's really important to pick trials where one is changing and the other one isn't. If you're changing two things at one time, it is going to mess up your answer. All right, so I need two trials where A is changing, but B isn't. So I'm going to look here, be like, okay, in the first two trials, trials 1 and 2, B stays the same, but A actually triples. Now, if you're looking at these and you're like, oh, I can't tell like what's going on, if it's doubling or tripling, just do the math. Do the bigger one divided by the smaller one. Now, always do the bigger one divided by the smaller one. Otherwise, you're going to get fractions and it's going to be confusing. So I would do 0.75 over 0.25, and that's 3. So what that means in these two trials is that I tripled A. So then you have to look at what happened to the rate. Well, it went from 7.25 to 21.5. Again, if you can't easily tell what happened to the rate, divide the bigger one by the smaller one. So I would go 21.5 over 7.25. That is also 3. Now, the way that you figure out the power is you do this value to the, we're trying to figure out the power, I'm going to call it equals this value. Okay, so I would say to figure out A, I would say 3 to the x power equals 3, and then you would solve for x. Well, in this case, of course, it would be 1. So that means that it's first order in A. So writing my rate law, I would write rate equals K times A, and you don't have to write the 1, it's just assumed a 1. Okay, so now I want to look at B. Here, series 6. Okay, so I'm gonna look at B. So now I need to find two trials where B changes and A doesn't. Okay, so I would do, there we go. B changes and A doesn't. Well, A is only constant in trial 2 and trial 4. So I'm going to use 2 and 4. All right, A stayed the same, B doubled. Again, if you can't tell, do the bigger one over the small. That is 2. All right, so I doubled B. What happened to the rate? Okay, again, if you can't tell, obviously this one stayed the same. But if you can't tell by looking at it, do the bigger one over the smaller one. So 21.5 over 21.5 is, of course, 1. So I'm going to do the same thing I did earlier to figure out the order. And it is this to what power equals this. So 2 to the x equals 1. Stop. So 2 to the x equals 1. Well, anything to the 0 power is 1. So if you run into this case, that means it's the 0 power, which means it shouldn't be included in the rate law. So I'm not going to write B in the rate law. Okay, so this would be the answer. Now, if you're like, well, then what would it look like if it was second order? Well, if it was second order, let's make up some numbers here. I'm going to use trials 2 and 4 again. So we doubled B and it would quadruple. So what is 21.5 times 4? Okay, so 21.5 times 4 is 86. So say this was 86 instead. Okay, so I'd be like, okay, well, B doubled, and then I want to know what happened to the rate. So I would do the big one over the small one. 86 over 25 is 4. So again, 2 to the x equals what in this case? 2 to the x equals 4. Well, then x must be 2. That would mean that it's second order. And that's really all you're going to see, I think, would be 0, 1, or 2. You could do 3 or 4 or whatever, but 0, 1, or 2 are going to be really easy to spot. And then those are the ones that you'll run into.